Hello, thank you for joining today's webinar, How to Start and Run a Data Science Project in Automotive R&D. The webinar is going to be recorded, so it will be available as replay afterwards. We would like to make this webinar a little bit interactive. We will use Slido for this. You will get a QR code and a link, and in Slido you will also find a couple of useful links for more information about us. At any time during the webinar, you can drop your questions in the chat, or if you prefer to ask your questions anonymously, you can also ask your questions in Slido. Now, I have got a quick warm-up question to you. Are there any specific topics or questions that you would like us to discuss today? Oh, multivariate time series forecast. So we will ask our experts to take a little note of this. And if there are no more questions, then I will hand over to Stéphane Foulard, who is today's host.
So hello and welcome everyone to our webinar, How to Start and Run a Data Science Project in the automotive industry, and especially in research and development. I'm Stéphane. I'm one of the co-founders and the CEO of COMPREDICT. We at COMPREDICT, we understand data science as the combination of domain expertise and computer science. This is why we are organized in such a way that our data science team is having a co-leadership. So I'm really pleased to this extent to welcome Zeller and Ousama Esbel for today's webinar.
Hi, so my name is Ousama Esbel. I am the head of IT and software team at COMPREDICT. My team consists of various profiles in IT, such as software developers, web developers, DevOps, machine learning engineers, and data engineers as well.
Hi, I'm Martin. I'm head of domain expert team. So this means in my team, we have data scientists with various knowledge, but various background and knowledge understanding, domain knowledge understanding, such as mechatronic, vehicle engineering, electrotechnic, and so on.
All right, then let's have right now have a look at the overviews of today's webinar and what we'll be tackling. So first, we will address the point of what are you aiming at achieving? Yeah? What are the use cases? What are the targets you have to take care about? How it is looking like? Secondly, we'll speak a bit about data types for data science projects, so which kind of data you have to consider and how to manage them. Then to speak about the availability of the data you need, because to know which data you need is the one point, but to make this data available is another one. Then we will speak a bit about our approach for data acquisition and data culture, because this is an important part of data science to develop and to help people in your company to develop a data culture. We will speak as well about data quality, data pipelines, and how we can handle this with the pragmatic solutions. At the end, or just before the end, we will speak a bit more about machine learning and artificial intelligence, and especially about topics like how can you trust model that you were developing with machine learning, and maybe this will be the place where we can tackle these questions about multivariate time series application. And finally, we will make some Q&A with you. All right.
So maybe before we start, it would be nice to hear from the audience if you have ever started or worked in a data science project. So maybe you can access the slido.com with this code and just let us know if you are worked before in a data science or not. So we can say, wait for a few minutes, but it seems we have an audience of everything on this.
Yeah, this is quite interesting. So that we have people having already experience, so frequently working on data science projects, and some people thinking about starting one, so meaning maybe not having that much experience. So hopefully we will address for everyone a bit of the questions you might have for today. Okay, so this is quite interesting to have this kind of audience today. Maybe we can start with the actual content of the webinar for today. So maybe Ousama, you can maybe tell me what should a customer do first before or when starting a data science project?
Of course. So at the beginning of a data science project, you have to frame your problems. So you have basically to put your objectives, questions about your application in words, and then look at the big picture. What are you trying to achieve ultimately? What are the use cases or the business cases you are trying to address?
Okay, yeah, this is yeah a good point to start. But when we are speaking about automotive R&D, maybe Martin, what are the kind of more concrete targets we might have in this extent? Yeah.
Of course, there are many different possibilities, and every customer can come with his own specificity. But I would say we can draw some big lines, and it's often by better designing a component. And this means, for example, reduce the cost by less material, and this means also reduce the weight or reduce the CO2 footprint. But there can be also some bigger picture, I will say, open new business opportunities, like after stage or predictive maintenance, to really act directly at the end customer level to reduce or forecast failure. We avoid some recalls. But it can be also on the R&D, which is our topic today, is to shorten the R&D phases by being more efficient, by better understanding some possible failure to predict, forecast them always in advance, and win money at the end.
Yeah, of course. Yeah, those are good insights, and I think okay, the first step before starting anything is to be crystal clear about which kind of goals you have and the targets and the overall picture, as you were mentioning, Ousama. So let's say that now, okay, we have the use cases, we have the business goals. Then the question is which kind of data are likely to be used in automotive R&D. So maybe Ousama, can you give first quick introduction about which kind of data we can use in data science?
So basically, data science, in a simple words, it's about problem modeling using data-driven approaches. And there are various of data that we can use. It can vary from time series data. It can be images that comes from the cameras, lidars. It can as well be a language where it can be analyzing text or speech as well. So for each data domain, we can apply different kind of approaches and techniques that can vary from a semi-physical models to a really black box, complicated neural networks.
Okay, all right. When we are speaking about vehicle in particular, which kind of data, Martin, we can really use in automotive R&D?
So currently, there is plenty of sensors in any vehicle on the road everywhere, and these sensors are connected to control units, and there are many control units in the car, and they are exchanging a huge amount of data. And this is typically a kind of data we can use. But additionally, in research and development topics for car, you can add some lab sensors, for example, strain gauges. And this is very dedicated sensors to access some key features used by engineers for designing purposes, mostly. And this is typically the data we are interested in for data science project in R&D in automotive domain. And this is, so here at COMPREDICT, we focus on time series as Ousama presented, but we tried in this webinar to give some guidelines which are true for any kind of project, any kind of data, but we are more focused by COMPREDICT on time series.
Yeah, that's true. That we have this kind of focus on the time series applications and taking information from sensors and from signals in vehicles. Of course, from a CEO perspective, data science can be applied in a lot of different departments, especially in the automotive industry or for suppliers as well, not only manufacturers. So you can use data science in marketing, in procurement. You can also use for risk mitigation, cybersecurity. So there is plenty of applications. You were mentioning as well predictive maintenance or after sales. But on very engineered focused aspect as well. So actually the topics we are in at COMPREDICT, when it's about vehicle component design, when it's about reliability management, and so on. So right, yeah. Then okay, we know now the business goals, and I know which kind of data I will need for this. Then what should a customer do next when starting a data science project? Yeah, Ousama, maybe.
Data, which is a key in data science projects. You have to check your available data, and luckily we live in a time where it's very easy to measure or collect data. So it can be any kind, like I mentioned before, a timestamp data, it can be a language or whatever it is.
Okay, but then practically speaking, how can you access this data?
So I will specify on vehicle and industry, but there is many different ways to access data. It can be really old school handwritten report from a workshop or from a test, or it can be something with get some data gathered with an old school data logger which is not connected, or really step into the near future, the oncoming trends, fully connected vehicle, gathering and sending automatically data to the cloud. So there is several ways, and all are right.
Okay, so this means that basically you can use a lot of different sources of data, and you can go, let's say, as you were meaning, from old school a way of collecting data up to highly automatized data pipelines. Yeah. But assumingly, I would say that data have different degrees of quality, yeah, because I'm assuming that one given data might have a better insight or better value than another one. So maybe, Ousama, can you tell me a bit more about this by data quality?
Of course. Data quality can be assessed with the three kind of terminologies. So we call it, we can, about how relevant the data is, so we call it this relevance. We care about the frequency of the data, and there are two types of frequencies. So we have the sampling rate frequency, which is the number of inputs per second, or the update frequency, which is basically how often you have access to such data. It's important to know the accuracy of the data, how good the information that we acquired.
Okay, so let's mean that, let's say, okay, you're taking care about the relevance, the frequency, and the accuracy of your data.
Yeah.
Are there any no-go criteria with regard to data where you say, okay, I cannot work at all?
No, there is never good or bad data. I would say it's always a trade-off between your business goal and the available data. So, and here I will link again to the big picture, what we discussed at the beginning. What are your business goals? So you can, with high-end data, with very high-quality data, you can reach lower granularity, more precision into your results. So maybe let's consider an example to predict the wear of the brake pad, for example. With very high-end data, with very high-quality data, we can predict the thickness of the brake pad with a sub-millimeter precision, so something very specific. But maybe with less data, we can still predict something, but it will be just a status, so a kind of light, green, yellow, red, saying to the end customer, okay, should I take care of my brake pad, yes or no? And this is also interesting at the end, and it's always related to your business goal.
Yeah, and I think it's a really important point to say that basically you can still address your goals, still address your business case, still address your use case with different quality of data. Maybe you will not reach the same granularity in the results, but you can still address your business opportunity. So this is important to mention. Because we know all of us, yeah, because we are confronted to this as well, that a lot of customers are worrying about their available data and sometimes the quality of the data. And sometimes as well, we're capable to increase the quality of the data with some approaches. So maybe you can tell me a bit of our magic recipe, how to extract result out of incomplete or limited data.
Yeah, as you said, so we have a lot of algorithms in our arsenal where we can enhance the quality. So basically, we can interpolate missing information using imputation learning. We can extrapolate data from the history of past data from what we have using supervised or generative models. We can enhance the data using our virtual sensor technology, or we can as well run some algorithms for identifying maneuvers using unsupervised learning. So there are actually a lot of approaches, and in a nutshell, basically, incomplete data is fine for you to start a data science project. So basically, what you really need is the sequences in the data, and that's what's really important.
And I think this is a great insight, because this is meaning that even if you are lacking at some available data for some given driving maneuvers or for some driving point of time, you can still maybe enhance the content of your data. And I think it's really important to mention, because it's something we are dealing with sometimes and we have solution for. So I was mentioning it before during the introduction. Yeah, we were meaning that the concept of data culture. We were speaking about the data pipelines as well. So I think those are two important aspects when you're dealing with data science. So maybe Martin, can you share a bit about these according to your knowledge?
Yeah, the data culture is actually a big picture that you should always keep in mind, and ensures that once you start an internal project in R&D, or even once you drive a car for any purpose, that you are gathering data. And not only gathering, but gathering in a good quality, then to ensure that these data are saved at one place, centrally managed, and that this data should be available to, first of all, you and also your colleague. And this is actually one of our core solutions. The core of our solutions, that we can offer to customers some solution to log data, so a data logger fully connected, which ensures that you are gathering all the data in a reliable way. Then that we are offering also some data management solutions, that all your data are saved in one place, and on top of this, we are offering some visualization tools. So basically, this allows to engineers with mechanical background, for example, so no knowledge about data engineering, database, and so on, that this visualization tool enables them to access the data easily, quickly, and also to fulfill their purpose, really.
Yeah, and I think it's really important to consider this as well, because when you are speaking about gathering data, this is the one point. Gather data is something you can do, but we know it from a lot of customers that sometimes they are gathering data, but this is done in a very isolated way. So this is meaning that each department or each group of employees by the customer is having its own data pool, so to say, and that there is not central administration, and this is a really important point. But as you were mentioning, gathering the data and centralizing the administration, this is not the end of the game, yeah, because you have to make it accessible, yeah, for the people. So internally, actually, for your employees, but as well maybe externally for some partners or for your own customers at the end. So this is I think really important to consider. But okay, so we have our business goals. We are thinking about the data. We have access to the related data. What is now the next step?
Okay, maybe very pragmatic is, okay, now data scientists should analyze the data, have a look to the data, just to refine and to refine the business goal. So according to your business goal, say, okay, what is exactly the use case? And in a very concrete way of doing this means that a data scientist of COMPREDICT, of course, should analyze the data, say if something is missing, if the quality is good enough, and then make some proposals, some hypotheses on what can be reached, and to make it to discuss with the customer regarding the business goal. Then we are usually running a quick and rough test just to validate if we can train with the data we have, and then at the end we are assuming we are evaluating how many efforts this will require to meet the goal and to reach the business goals.
Okay, so the process is quite clear. So going from refining actually your business goal up to actually estimating how much effort you will have to put in this, and then you can put it in regard to your business goal, because if you need way more time and way more money to achieve a given goal, maybe it's not worth it, but this is something you are refining at this stage, and it's really important to reflect back actually when you have the data available and the quality you are capable to reach, to look at your goals you had before and to try to optimize or to improve actually your plan and your timeline. Okay, so let's say that now we have all the requirements are fulfilled and we know how we can start to train the models, we can do it, and this is all fine. But well, data science, and especially when we are dealing with machine learning and artificial intelligence in a more general sense, I think for a lot of people this is still a bit obscure. And I'm thinking about those participants telling I'm planning to start a data science project in the near future, that maybe they are not feeling that confident when dealing with such approaches. So maybe Ousama, as a machine learning expert, can you tell us which are the reasons why we can believe actually in artificial intelligence, especially in machine learning, and how we can make sure that you can trust the results which are generated out of machine learning?
Yeah, that's a key question actually. So machine learning actually extract information in a really complicated way for a human to comprehend actually what's going on. And it's very important for us to understand why the machine learning is behaving this way, especially when it's in deployment, when it gives decision about something. That's why in COMPREDICT we value interpretability. So it's really important for us because it helps us understand the relationship between the inputs and the outputs. It helps us understand why the model is giving such a decision at a time step. But in a machine learning pipeline, modeling is not the only thing to make it white box. We need to white box everything else in the complete pipeline. So we as well look at the data drift in the inputs and outputs. We looked at the distribution of the data, how they converge over time, how they are shifting, and so on. Yeah, so this is really important.
Yeah, and this is, I think, a point that maybe if we are thinking back to the question about multivariate time series, those are usual approaches that we are using for them, yeah, because as we were mentioning before, we are specialized in the domain of time series, and we are quite exclusively working with multivariate time series, and those are the kind of approaches we are using internally when dealing with the data. So maybe a bit from your perspective, Martin?
Yeah, and this is from the IT perspective, I will say, but we have also, by COMPREDICT, the domain expertise. And I will speak more from an engineer point of view. We will also validate that the inputs are making sense. For example, if I predict the brake wear, to know that the driver has opened his window is not relevant at all. But it might happen that a model takes this as input. And here we are acting directly and saying, no, you cannot use this feature, for example. So we are always thinking, okay, make it sense. Is it purposeful to use this input feature? And we also validate the output, make it sense from a dynamic point of view. And we can also validate with rough rules, rule of thumbs, just to say, okay, is it correct or not? And we are also, but at the end, it's a combination of several approaches, which can build, thanks to it, we can build trust in our model and our predictions.
Yeah. And I think that what you were saying, both of you, this is actually the key point, and we are closing the circle back, where we were mentioning at the beginning that data science is a combination of computer science and domain expertise, and this is why we are organized in such a way with this co-leadership, and this is explaining why, because from the computer science point of view, we are looking at specific interpretability aspects or at statistical distributions and so on. From a domain expertise point of view, we have to look as well that the model from a physical point of view is meaningful, and as well that the shape and the dynamics of the outputs we're generating is as well purposeful. All right, so maybe let us right now a bit wrap up the main points of the webinar we're tackling today. So first, this is important before even starting your data science project, that you are defining the business goals, the use cases, the targets, what do you want to achieve, to which extent. Second, checking input data. So meaning what is available, what I'm capable to gather, access to the data, what is the availability of the data, what is the relevance of the data for my business goal. Third, to ensure consistency and centralization of storage and of access of the data, because this is important if you have a data science team to be able to share the data with them and that they can access it easily as well. Fourth, when you're then applying your data science approaches, or can be machine learning or any kind of other data-driven approaches, to evaluate the quality and the behavior of your model. And last point, but relevant as well, is to ensure that you have meaningful relationships between your inputs, so-called the features in machine learning language, with the outputs, meaning the target. Yeah. And those are, I would say, the 5 steps you are really to consider when running a data science project. So we at COMPREDICT, I was meaning before, we are specializing in data science, and as you guys were mentioning as well, we are specialized in virtual sensing. And virtual sensor, this is actually something which is using already available in-vehicle data to generate new insights with artificial intelligence-based, or at least machine learning-based methods. Yeah. So with our visual sensors, we are actually able to provide detailed health and usage monitoring of various vehicle components, like wear components as brakes, tires, low voltage, high voltage battery, or as well non-wear components. Yeah, so we are looking at components like gearboxes, steering systems, suspensions, and so on. So if you are interested in this, feel free to get in touch with us, to contact us, and we can help you to digitalize your R&D processes. So maybe now let us check if there is any questions from the audience. In the meantime, we will be able, really happy to answer them.
Sorry, it took me a little bit of time to centralize the questions. As you said, centralization is key. One first question, can you give an example of automotive R&D applications you work on?
I can maybe start, so for one particular car manufacturer, we are following mainly their fleets of electric vehicles during R&D. This is for reliability and dimensioning purposes. So here we are really applying our end-to-end solution. So we are equipping the vehicles with our data lover so that we can be sure that we are accessing the right data with the right quality, that we are gathering the data, that it's centralized and easily accessible. So summarizing actually everything we were mentioning today. Then we are using this data to train virtual sensors so that this particular customer can get access to additional information in this test fleet, and then we are using the data from the vehicles, the output from the virtual sensors, for making usage monitoring and usage prediction. So this is more in the sense of using this information for development and for generating requirements for designing components. And we are giving them access to our visualization platform. So this is covering, let's say, all the aspects that we are addressing here at COMPREDICT.
Then there is one question, I'm not sure, possibly you have already answered it to some extent. What is if your data is incomplete, how does this affect outcomes? Can you just please wrap up that again?
Yeah, I can maybe just start and then you can complete on this. I think, so maybe just from my point of view, because you were mentioning the break aspects, yeah? So this is depending, I think, where the data is missing. Because when you are speaking about, for instance, the breakware, to take this example, again, what you are interested in is actually only the time where you are breaking. So if actually you are missing data, but you are not missing data while breaking, actually it's not an issue at all. So I think that first you have to think about, do I need actually this missing data or not? Yeah. But maybe we can wrap up on solutions to.
Well, I can say from the computer science part is basically if collecting the data is expensive and it's really required, unlike what Stéphane mentioned, is there are multiple ways to create an authentic data or to fill in the gaps in the data. We can use some kind of imputation learning where it just learns from the behavior of the past data to predict how the data would look like in these gaps. Or we can as well generate an authentic data using generative models such as GANs or variational autoencoders as well. That's only specific use for time series that studies the data that's already available to fill in these gaps or create an authentic data behind it.
Yeah, I can maybe add some. There is always a possibility to complete this data with virtual sensors also, because as I said, there is plenty of sensors in a vehicle. So maybe you are missing one signal, but some others are giving you the same information just by not a straightforward way. So, and here we can reproduce this, recompute this. And there is also some possibility to evaluate the data quality with the points Ousama mentioned. So if you are able to know, okay, at this moment, at this situation, my data was not as good as I expected, we can also take it into consideration in the model. So there is a lot of different ways and to get rid of this limitation. And I would say we always work in a very pragmatic way, and there is always solution.
So if I try to summarize, so first is the question is if the data you are missing are critical for your use case. The second point is if yes, probably you can apply some machine learning approaches as Ousama was mentioning, so you can maybe interpolate data, extrapolate data, and so on. And the third aspect is if you are missing a data, which is actually not because you are missing some data points in a given signals, but you don't have access to these signals, you still have the possibility to apply some visual sensing approaches to generate this non-measured or non-measurable information.
There are more and more questions coming in. One more question about data. Time series data is usually pretty big. I think it was confirmed. How do you cope with this? How do we cope with this?
It depends on where is it in the pipeline, basically.
Yeah. So, well, that's true. So time series data can be very big, especially if you are speaking about signals being exchanged between control units, as Martin was saying. Yeah, those are gigabyte, terabyte of data which are generated within a week, within a month. Yeah, so this is quite incredible, and this is still increasing. Yeah, the size of data which is generated. The first point is, as Ousama was a bit saying, it's a bit depending where you, at which stage on the pipeline you are, because obviously your model will not take all the data which are available in the vehicle as an input, but you might have to handle all the data available at the first stage to select your features. So we are mainly working mainly on the cloud, because on the cloud, as you probably know, you can just extend the computational power, you can extend the storage capability without doing nothing actually. For some particular aspects, when it's about R&D, for instance, and we want to train new models, we might use some internal servers as well with GPUs, but when it's really going to big data, we are running on the cloud. So something we were not mentioning today in this webinar, because we cannot tackle all the topics, is that especially when dealing with lots of data, so big size of data, at a given point, you have to think about the concepts of data lake and of data warehouse. So this is meaning having processes, having functionalities, taking care of the ingestion of your data, taking care about preparing the data in the right way, because there is also an aspect that maybe you were not meaning with your question, but that you might have different formats, different shape of the data you have, and you have to put them into the same shape so that you can use them in your data science process later on. And when speaking about data lake and data warehouse, then you are dealing with aspects like preparing the data the right way, making it efficient, having an efficient access. So at a given point, you have to think about having databases and so on. So this can be really complex at a given point. But if you have the right setup, I would say that at the end, you don't care if you have a lot amount of data or less amount of data, because everything will scale automatically. So I don't know if you want to extend some aspects on this.
There are some aspects I would say, yeah, you can definitely scale. But if the question was more really very concrete on, okay, I have a car and I cannot send so much data to access it, I will say there are a lot of possibilities and techniques of data reduction. And this is, again, something which has to be taken into account since the beginning, since the target and the use case definition, because we will not apply the same model architectures or the same techniques, but this is something we can definitely deal with. There are techniques, as I said, to data reduction, and some algorithms are not using so much data, even if we are working with time series. So this is definitely something where we can think about using in series production.
Yeah, that's true, but I mean that especially regarding R&D, when we are gathering data, for instance, from this customer I was mentioning, where we are implementing the data logger, gathering the data, so we are more or less making a dump of the bus, yeah, and this is actually something which is nowadays manageable if you have the right architecture and infrastructure.
Okay, thank you very much, everybody. There are still a couple more questions. I will try to follow the pipeline or the stream of a project. So when we go into how our algorithms work, do you rely on traditional machine learning techniques, or is deep learning the key to create value from data? Was one of the next questions.
Yeah, I think I will let Ousama extend this, but I would say that so maybe to answer the question this way, so we are working on data-driven approaches. Data-driven is meaning that we are not exclusively doing neural network or deep learning, but we can deploy model, random forest, or gradient boosting, or any kind of other machine learning models. We are dealing with stochastic modeling as well, with statistical modeling, with genetic programming. So there is a wide range of models that you can tackle. Deep learning, this is the one possibility. This is not the only one. This is a powerful one. You have obviously to take care about some aspects. So overtraining is the one specific aspect you have to avoid as well. But let's say that from our perspective, there is not the one solution fits all. So I would not say that deep learning is mandatory. I would say that depending on your business goals, depending on your available data, depending on the accuracy or the quality you want to reach, deep learning can be the answer, but must not be. Yeah.
Yeah, actually, what you said is correct. It depends actually. So if we are looking, so always the simple, the better it is. Okay, so we don't need to go to something really complicated to do something really simple. So if something that has a really a linear correlation with the data, then we can go with a linear regression, for example. We don't have to create a neural network for it. But some aspects sometimes where the data is somehow interconnected non-linearly, and they are really so they are correlated to the target in a really complicated way. Then we go to the more complicated neural networks. But of course, like we said, we value interpretability. So we go always with a model that help us understand why the decision has been made, and so on. And of course, as you said, so we don't usually go with a deep learning unless it's necessary. And we are actually trying many algorithms as well.
And I think that this is important. And so one point is machine learning is nothing but mathematics. Yeah, it's nothing but statistics. So you have to understand the right statistics and the right mathematical approach. You were mentioning linearity, non-linearity, depending on the not correlation, but let's say the relationship between the data, you might go for the one solution or the other. But I think that the most important answer was given by you, Ousama, is as simple as possible, as complex as necessary. Yeah. And actually, this is the rule you should follow for your project.
Yeah. Thanks a lot. Ousama, Martin, and Stéphane. One more question. What are the expectations from the visualized dashboard at the endpoint by clients? I'm not sure if we can treat it today or if we can do it as in a subsequent webinar. Can you just, we are a bit over time already, can you just answer very shortly, please? What are the expectations from the visualized dashboard?
Yeah, this is my preferred answer. It depends. So it depends actually on what you are doing. So we have some customers, especially in R&D, they want actually to have access to our visual sensor technologies because they want to access signals in time series which are usually not available. So basically, what they want to visualize on the platform, this is the time series. They want to get access to this, to be able to download them, so that they can maybe make additional analytics later on. When we are dealing with the special case I was mentioning about reliability, durability, what the customer wants to access is what is the current health state of my component. So we might have a visualization of the damage or the fatigue state of the given components and maybe make a forecasting when it's going to fail. We can as well display usage profiles, which is something which is actually really used in R&D as well to know how my component, how my vehicle is going to be used. So I would say that basically the customers, if I have to give a general answer, you want to access the data on a trip basis. So each time he's running the vehicle, you want to access either the time series or the current state or the current usage. Really general, but it's a case-by-case basis. Yeah.
Okay, thanks. And one related question. What kind of tangible benefits are possible for automotive R&D out of this methodology?
Yes. So if I go back to the end-to-end solution I was mentioning before with data logger up to visualization platform and visual sensor. So here we are helping our customers to reduce the cost of their test fleet by almost 90%. So this is a huge cost reduction. Yeah. We are helping them as well to be much quicker, which is at the end kind of cost reduction at the same time, but faster in the development process. So, for instance, we have the one particular application cases where they were able to reduce the development time from 1 year to 3 months with our visual sensor approaches. But all in all, if we are following all the phases of the R&D process by the automotive industry, I would say that we can reduce the cost by at least 20% of along all the development process.
That sounds very good. How can be assured, was the next question, how can be assured that the result data quality stays high over time? Is there any way to verify? Ousama, you've been talking about drifts. Is that the answer?
Yes, that's true. So monitoring the drift of the inputs and the outputs is really key in production. So once we deploy the model, we need to make sure that the model performance does not degrade. So that's why we monitor the data in and out to see if there is kind of a drift in the model. And when this happens, actually, we do some kind of continual strategies to refit the model and update and make sure that the model is up to date with this kind of drifts and so on. So we have kind of R&D projects for continual learning research, and we are looking as well and keep track of the drift of the data. This is really important.
Yeah, this is a good point, and I think there are two aspects you were mentioning. Is first, monitor your model.
Yeah,
you monitor the inputs and outputs, and basically you are looking if the inputs and the outputs are still in the statistical distribution of the model you were training, so that there is no drift to this extent. And I would say if you are seeing that there is actually something going wrong, or this kind of drift, or any kind of other aspect which can occur, then you might think about refitting the model, and this continual learning strategy are purposeful for this. Yeah.
Okay, thanks. A related question: what are the most common errors in the targets or / in the data that you see during your projects?
So this is we are smiling because there are I would say always kind of similar things happening. So if we are using the data to train a virtual sensor, so sometimes we are using a reference measurement, which was measured with an additional sensor, which is at the end not available in the car, but at a given point was measured. So here we might face, I would say, two kinds of problems, but maybe you can extend on it. The first one is calibration of this particular, or maybe three. The first one is calibration of this particular additional sensor, so meaning gain and offset. The second point is potential dependency with some environment variables, so like a drift because of the temperature, which is actually not something you would like to measure, but it might happen, so you have to get rid of it. And sometimes noise or issues or problems in the data, so like wrong point or non-available values and so on. So you have to clean actually the targets.
Yeah. Definitely some outliers, or there are the power supply which is fading off or something like this. And we say this is one of big target, especially when we are making long measurements, that it's not consistent over time, that it's changing at a given point, and this can be a problem.
Yeah, but for this,
So speaking about the outliers, because sometimes it's really difficult to define this point as outlier, and sometimes we define it as a really rare maneuver in the trip. So this is sometimes difficult, and this is sometimes we really need the domain expertise to define this sometimes, because maybe a special event occurred once in multiple trips. Sometimes we define an outlier, but it's really important for the target.
Yeah, this is really important, and this is where, as we were mentioning, domain expertise is playing a big role. It's like if you are driving a car and you are measuring something, the suspensions, for instance, and you are driving over a pothole, so you will see a big outliers, let's say, in the time series, but this might be actually okay. This is a real one. And on other events, you might have an outlier which is actually due to the measurement chain. This is not correct, and you have to take care about this, of course. But it's all, I would say, topics of data preparation and data cleansing.
Okay, thank you. I think we're really running out of time. Thank you to everybody for staying so long, for your endurance. Last thing we would ask you to do, can you just go back to your Slido, please, and tell us if you have any topics you would like to be treated during our upcoming webinars. So please don't hesitate, take your mobile phone, go to Slido as before, and tell us what you would like to hear during upcoming webinars. That's very, very helpful for us.
And from our side, so we would like to thank all the participants of today and also those who will watch the webinar afterward as replay. And thank you, Martin and Ousama, for being here today and sharing your expertise today. If you have any questions, if you want to get in touch with us, do not hesitate to contact us at contact@compredict.ai. We are really happy to continue discussions with you. Stay tuned for our next webinars in April and May, and see you soon. Bye-bye.
Thank you. Bye-bye.